we live in interesting times, people assume that's kind of a Chinese cuss word, but it's not. But nevertheless, a lot of disruption going in the industry. The first thing we all know about is AI, whatever that means to whom. But nevertheless, you cannot have a week without an AI event. I mean, there was an AI event already last week, I think. I was kind of invited and I had to jump out. And you will, as you can imagine, hear about that a lot today. We have this pattern recognition and then everything, including prediction, going on and machine learning. The other thing, which is the big change, is automotive. It's not that much of a change. 1980s, I come from Germany originally, right? We've been having this discussion. And in around 1990s, we've been already having 80 plus chips on high-end cars. 80 plus, I say ECUs maybe is the better form of describing what they are. So very complex systems. And then everybody was saying, we have to have central computer. Actually, there was a central computer project between Microsoft and Motorola in automotive in early 90s. It feels like Groundhog Day. And automotive is coming back with vengeance this time. So we have a much higher number of high-priced semiconductor. That's the good news for us, right? Most of us are from the semiconductor industry because ADAS is driving it, right? Driverless cars. Again, you cannot be on any city without seeing one or two of them. Vehicle-to-vehicle communication, vehicle-to-infrastructure communication. All this is quite interesting because newcomers, people trying to put their feet into this chubby waters. So we try to help them, as you can imagine. And the other one is the famous IoT, right? Every year we are saying next year it's coming. And I guess next year it will be coming again. Nevertheless, I'm starting to change my mind on this one. 3 years ago, actually, like my boss, Art, we've been making jokes about this, calling it immensely optimistic things. But nevertheless, now IoT was, I think 2 weeks ago, on front page on Economist. So if something like this is on front page on Economist, you can assume it's coming. Because this is the last newspaper, you are expecting that there will be a big piece of IoT. And we are seeing that now more and more, at least in the chip production or at least in planning, whether it's coming from the wearables or smart cities, connected vehicles, and whatnot. All that will drive IoT. And then we are thinking we did all right choices to be a key player on that one, especially with EM product line. The famous, hockey stick curves, right? Artificial intelligence market growth, discrete devices, will go through the roof. Integrated devices go through the roof. We will all get rich. All that is, I think, real. What is real as well is nobody really knows what is the winning strategy yet, right? But there are a lot of trials, and I think our IP, especially the EV product line, is showing a lot of promise. I mean, you did see the press release yesterday, especially in automotive. We have real things going on, and then we have IoT, mobile, data center, and whatnot, all growing on that one. And we went with the machine learning so far down. For the ones, EM is a 3-stage pipeline processor, kicks competitions, I think, behind in every aspect from the power consumption to performance. But further on, we've been doing significant improvements in our ecosystem. This is an open source activity, right? The machine learning libraries, and they are mainly around inference today, optimized for low power. So you will see more and more edge of the edge, sensor level, machine learning, discrete devices, taking some of that cloud heavy hitting work away. And we are talking about 16 times more performance against usual suspects. 5 times better performance in RNNs. So this is something we are talking about. Couple of microwatts type of environment, and then in that corner, it is doing its job very, very well. So please do go if you are interested in machine learning, and I don't know who is not. In the meantime, this became the main thing. A machine learning track, between 2 p.m. and 2:45 p.m. especially, we will talk about the leveraging the RNN networks, efficiently processing sequential data. Now, the MLI workshop is full, right? Surprise, surprise. But maybe you can get in still if there are some people jumping out of it. Like every event, there is always somebody changes his mind in the morning. AI more and more enables devices to see. And as we started this journey, again, it was sub-1 TOPS. Actually, it was 0.1 TOPS. Key automotive customer we had just 5 years ago saying, this is more than enough. We don't need anything like even half of a TOPS. That's too much. And too much power consumption, too much this, too much that. Same customer, different people in the same customer, but it's saying today 100 TOPS is not enough. So things change within 5 years dramatically. But nevertheless, whether you are doing front cameras or super resolution or scene segmentation matched with object detection, or simple things are facial detection, you need something expandable, configurable, with the same software front end, because that's where the cost is, that's where the development is. And I think what we did with our product lines, that you can move from an EM type of environment, lowest of the lowest gate counts, to an EV, which is going, I'm sure that you did see our EV7 press release, with 35 teraops and beyond, and zillions of max, and this and that. So you can cover basically both of those things with the same environment, same smart environment, and that's a big, big, big win. Nevertheless, EV7, is now available for you to purchase. I'm sure there will be a couple of sales guys trying to sign you up, but nevertheless, look into that one, because that's where the direction is going. And trust me, this is not our last innovation. We've been doing AI, ML cores now for a while, so you can assume, where the next big jump will be. We are talking about 14,000 max. The first project we had only had 100 plus max. Right? This is just 5 years ago. So this addresses the market requirements for broad range of vision applications and very fast neural networks, and importantly, high bandwidth encryption. Your data is becoming more and more important for you to protect, and more cameras are around, more things are getting seen which you don't want to share with other people. That's from the personal perspective. And the other thing is definitely the intellectual property, if it comes to coefficients, if it comes the networks and so on, that one you want to protect as well. So we are doing our utmost to protect your IP, to protect your confidentiality, and on top of it, we are doing things, everything related to safe, right? This is all driven by automotive industry. So this is another one which I strongly recommend you should look at, the EV7X family, brand new, 4:30 p.m. to 5:15 p.m., and then you will hear more about that one from our people. The other thing, and looking basically at average age here, it's not really a software group, looks like it. We've been doing this mistake year over year. This happened even from data centers to PCs. People try to take the same type of chip architectures and inherit it, because it's the easiest thing to do, in the next big thing. We made that mistake in mobile phones, right? We tried to make a small PC out of a mobile phone, which was a big, big, big mistake, and then vanished. And today, modern mobile phone technology became a standard. And I see the same mistake actually happening going to automotive. The automotive needs are different. You cannot just take a phone application processor. Maybe you can in the beginning, right? And then there are good examples in our customers doing that, and then be successful long term. So if you look at an ADAS powertrain or infotainment, the architectures will be dramatically different, and you have to invest for that. And you have to invest from the brain power, you have to invest from the interfaces, you have to invest from the smart safety. So there is a lot you can do. And we believe, we try to help you to accelerate that investment. With the automotive SoC development portfolio we have, and there is a lot going on within SG Solutions Group. And in my organization, with the ARC Functional Safety Processor IP, we are getting into, again, a new domain. We've been doing 1Z, 2Z functional safety approaches, and this is a pretty new movement. We have now a whole automotive family with the EM22FS, HS4XFS, EB7XFS, which is targeted specifically for automotive. So if you're an automotive customer or a commercial house trying to get into automotive, we are able now to give you a full portfolio, but you can put together very, very fast, get to ASIL 3 certification, and up you go. So if you want to hear more about that, again, between 2 p.m. and 2:45 p.m. in automotive track, safety first is the message there. Now, around those lines, this press release came out just yesterday. One of our dear customers, Infineon, is collaborating with us to accelerate artificial intelligence in automotive applications. And I know you see many press releases out there with more or less substance. This is with more substance. This is a serious project with a player who has significant pieces of the market share in the area. They are active, right? Infineon is known to automotive quality. And then I think jointly we will deliver products to the market which will resolve a lot of needs around AURIX. This is the next generation AURIX chip. And this is related to everything, I will say, data hungry and needs AI. More to be heard from Jürgen during the day, and between 11:30 a.m. in this case, and then 12:15 p.m. And you don't have to go to Newport Beach, but that's just the name of the room, Automotive Track. And I strongly recommend, if you are interested in automotive, to see and listen to Jürgen as an industry leader, what we are jointly doing. Now, the other element, which we promise every year, by the way, I am a board member in the 5G lab in Dresden. This is the leading lab for all 5G research worldwide. I think the one and only leading lab. There are a bunch of other things going on. So I know really what's going on inside in 5G and actually next generation. Last year I was in a panel, telling people pretty straight on, I'm not seeing the chips coming. This year it's a bit different. If you are looking the global market size for connected devices, again, another hockey stick, this will explode. With the same vengeance of IoT will be exploding in the next couple of years. They are competing standards, right? Sigfox, LoRa, NB-IoT, Narrowband IoT. Narrowband IoT with both 4G and 5G will be a significant change. We are demonstrating our capabilities about this now for a while with many partners together. I think our first demonstration was with GND together 2 years ago in Barcelona. Last year in Barcelona, we had a real infrastructure mock-up. This year, this is the real thing, right? This is the LTE Cat NB2 SoC implementation. Something smaller than a matchbox. Anybody can remember what a matchbox is? So smaller than a matchbox, and that one you can see again in the demos. And if you want to hear more about that, what we can do to help you to get into the NB IoT domain in a pretty smooth way, 11:30 a.m., 12:15 p.m. Addressing IoT connectivity with one of our partners, Palma SIA, Semi-Design. Palma guys do all the RF for this demonstrator. Pretty strong presentation. So in the meantime, we are running out of columns. That's it, I guess. If you do 5 or 6, nobody can read anymore. But if you look at our key families at EM, right, we started this journey nearly 10 years ago with the 3-stage pipeline, DSP optimized now, machine learning, and all those goodies. 3 microwatts per megahertz. This is something, right? With a couple of microwatts, you can do machine learning. I see always this press releases, 40 watts, 250 watts. It will be many EMs you will be using to catch up with that type of heater. But nevertheless, the performance will be competitive. SEM is our security processor. Security is becoming key for all of our applications, especially if you want to protect the data integrity. And that means you have to protect your environment against side channel attacks. This guy is doing a good job on that one. We got a Best Processor Award on the SEM a couple of years ago for people who can remember. HS, or highest performance, now new members of that one is coming, right? You see already HS3X, HS4X. Stay tuned. There will be more of those coming, as you can imagine. So high-end, sky is the limit. We can keep going till more and more embedded processing power is needed. Remember, we are still in embedded processing, right? It's not a dirty secret or anything, right? Intel is our #1 customer. They do an excellent job in processors, and we do a good job, I think, in embedded processing, and that's the I think work share we are having. EV family is I think our biggest success story in the last 3-4 years. We are already on the 4th generation of it, right? We started with the 5, 6. We ended the 2nd generation of CNN on the 6, and now the 7. It's a heterogeneous multi-core vision processor, and by the way, it's not vision anymore only, right? We do LiDAR with it, we do radar with it, and we do other things, which is proprietary to our customers on direct conversation in those demonstrations. You can get a bit more insight what else you can do with the EV family.
Good morning, everybody. It's really my pleasure to be here. It's actually quite of a nice introduction here from Jenkins, and I will take your description of my new job as a new way to talk about it. Actually, I kind of like it. Definitely, I had quite of experience across many other areas in the industry, and it's really a pleasure to go and talk about specifically AI, which is, as you know, everybody talks about AI. So, already coming in the next slide. So, the way how I usually talk about AI, and it's interesting, I go back, what's the definition of AI? And you can say, oh, everybody knows about AI. The interesting piece of it, it's, yes, everybody talks about AI, but many people are still actually quite skeptical. Is that really a wave? Is that really here forever? Is that kind of go away? Jankin mentioned about IoT, how we kind of used to think about it, and all these kind of new technology coming in. But I felt like when you really go back to the fundamental of the definitions, it gets you some insight to really tell you, is this going to be a wave? Or can we talk about another winter? Sorry, like we talked about in the early 80s. The definition of it, it's really said, it's a science. It's a multi-discipline sciences implementing method and system that manifest cognitive behaviors. It does have features, You heard about the learning, generalizations, inductive, deductive, reasoning, human-like communications, and also have some feature which kind of in progress, people are kind of working on, like consciousness, self-assembly, self-reproductions, even AI social networks. So it's quite profound in terms of what's this AI. And when I started looking at it, I tried to understand where this AI will get us through. My background starting as a physicist, then done a lot of development and chip development. It's always you want to know where is the ultimate point. And actually, there is a definition of the future of AI. We call it singularity. What's singularity? Singularity is a word that's been used mostly in math or in physics, describing what's happening in the bottom of a black holes. Here, AI, it's really meant to say when artificial intelligence will reach the human intelligence. And you can stop there. Actually, you can go even further than that, and it's describing a kind of an acceleration, actually like an exponential acceleration of intelligence, which is where people hear that. That's what's got people very scared, very skeptical. They don't know if they want to believe it. They don't know if they want AI, if it's something it's really going to be good for humanity. Hopkins said, you know, it could be the best things ever human has or the worst things a human has. And I think he's referring back to the singularity. I think he spent quite a time working on black holes, and he's making quite of analogy there, and he was a very smart man. The other things which people will describe it on AI, it's the evolution of a human being. Yeah, we evolved to the brain, and now everybody talk about information. Everything is information. It's like, and it comes back actually again to Hopkins describing what's happening in the evolving horizons in terms of are we losing the information within the black hole or not? And yes, the information is really stayed around the event horizons. Is that true? It's quite interesting. There is a lot of, I would say, scientists which is trying to look at from different perspectives and give us some insight where all these things could go one day. But let's stop here and making sure everybody understands. This is very, very far away. But nevertheless, it's a nice thing to kind of really understand. Now, AI, for me, it comes down to algorithms. Some people will say, oh, it's like statistical, it's bigger database, which we're trying to figure out what's the common patterns, doing machine learning, getting what is the optimum, getting all these kind of gradient descent, and yes, we can extract more information from the data. But this really comes down to the essence of all these advanced algorithms. And frankly, this is one of the reasons why I joined Synopsys. When I thought about, I really want to learn and do more about AI. And the reason for that is because all of us develop algorithms in all industries, but in particularly in our industries, with all our Moore's law and how much really we starting pushing the integration to another level, EDA got pushed actually very strongly to develop even more algorithms. They were forced to kind of solve more and more, I would say, algorithms issue around us. And they develop actually against all the other part of the industry, they are sitting on the most advanced algorithms, actually. And that's in my mind what's just really combined these kind of advanced algorithm, which was AI can give us, which kind of we are at the starting point of it, and we are in the early kind of phase scratching the surface to kind of learn about how we can understand it. And some people can also translate, oh, all this AI is like in the early stage of electricity, or the steam engines. We built the steam engine, but we don't have any understanding of what's really how things work. We didn't have at that time the thermodynamic, which really explained us about how things work. So many people believe we are in that stage. Machine learning actually will continue helping us advancing all these algorithms, and ultimately actually quantum computing will give us another level of advanced algorithms. Many people also kind of think, is that real quantum computing? We barely understand really how things works. We build these models. Yes, we know how to get it to use. Actually, as you know, IBM has announced their first quantum computing early in January. It's really available when people are trying to learn how to program it. And this will be a fantastic, actually, jump to continuing evolving on these kind of advanced algorithms era. Now, all this really, what's happened, it's really opened the door to another, I would say, a complete phase in our semiconductors. We always been struggling in terms of, okay, what's next and how we're going to continue growing in semiconductors, and this is really bringing us a phenomenal opportunity. And there's an explosion of, for the first time after decades, I've been in the industry for many years, and like many of you guys, we're starting seeing a new investment in startup to kind of develop hardware, which is really great things. And this is really being, I would say, enabled by automotive, 5G, IoTs, data center, what's happening at the edge, and all these AI things. Now, let's go back to kind of really close to our side, which is, I call it the AI design domain. There are many domains in AI, right? And the most famous one is being the gaming domains, where you've seen AI playing chess and then playing many different games and getting to a different level. In the AI design, the way how we think about it, it's like how we can really provide AI technology and to improve many of our flow to develop chips. And this is including all the different steps we do to develop chips. Would be within the tools, outside the tools, how to really provide that kind of technology and where it's applicable and how we can apply it. And as you can imagine, we started with the premise AI will help us out. We have a ton of data. We tend to optimize a chip architecture. We tend to optimize the implementation of the chips. So all we should do, it's a kind of optimization kind of approach. This is exactly what AI does. Now, the way how we look at, we have like 3 areas. One, what we can do in terms of our own tools. We have, I mentioned about these advanced algorithms. Can we really help making these advanced algorithms capable to solve these SAT kind of dimensions more efficiently? We also look at from AI chip development. So as I said, there is a lot of startups starting developing AI. The common things about many of these startups, which actually many of them turns to be happening in China, because China has decided to kind of invest significantly on AI. They really wanted to get ahead of the games and leverage that. It's the particularity of them, most of them, they have a good idea about what they want to run, what kind of applications they want to develop. But then they want to very quickly go to implement that AI accelerators and developing the AI chips. But most of them, there are applications kind of expert. They don't really have the domain expertise on developing chips. So actually, they've been coming to us and asking us, how can we help? How can you help us? How can you help us develop the chip, implement these algorithms they have from application perspective to develop these AI chips? So we're starting really thinking about what can we do for them. And I will kind of give you some sense about how we are approaching it. The other element is all this AI IP. You've heard about the EV. This is one of them, and we have many others capable to help out there. So these are first of all, as I said, attacking the tools. So we don't call it AI. Actually, we call it intelligence amplifications. It's the inverse of AI, I would guess. IA. And the reason why we're looking at that is because we are attacking it from very engineering perspectives. We don't just like playing as a black box and let's throw data, let's get the patterns. No, we are trying to really understand what's happening in that black box, what we are doing with that machine learning. So we are attacking it from that perspective and that mindset. We are attacking it to improve accelerate our quality of results, optimize power performance, implementing AI validation verifications, and also getting even to the flow. I mentioned about the AI flow, the complete flow. Ideally, you can see how we can get AI across all the flow when we get to the autonomous design. So we call it like this approach about can we do more from that perspective. As well as in the cloud. We are providing cloud capabilities, and we're trying to implement AI capability within our cloud. We're not going after the private cloud, the public cloud, as many other big companies, they do. That's not the intention. It's really to provide more services and more capability to our customers when they need it. So the other things, I mentioned about helping these chip development. So actually, we started developing tools to kind of help them out, optimizing the architectures in terms of how they can reiterate and improve the architectures. Many of these early chip kind of startup developing these chips, they run very quickly to develop their first prototype because they really want to see how it works. Are they have enough data? This outcome of this data is really giving them the right answer. And does it really work when they develop these AI chip accelerators? And now when going to the next version, the next generation, they're starting being interested about, is this the optimum implementation they have? So they really want to see if architecturally they can improve and how they can improve it. There are actually now even forum where we are talking about how we define a benchmark and how we can even have a measurement and a metric to kind of understand the differences between the architectures. We're also providing for some people, it's not completely ready, by the way, it's still under development, an end-to-end from taking the algorithm at high level, you write it in TensorFlow and Caffe or wherever your preferred way to kind of describe your application. We take that and literally we can go up to the implementation of the GDS, to the RTL, to the GDS. And that's really the kind of tools we are kind of contemplating to develop and get it ready. Another tools which we realize would be important, it's many of these machine learning, as soon as you start playing with machine learning, the big things you are facing, it's data, how to manage your data. It's everything about getting the most data possible. That's the way how you get the most of the learning. But how you manage data, how you store it, how you filter it, it's a big part of the work. So we're starting actually developing these tools for our side to help having a common infrastructure for all our machine learning projects running at the company. And we have quite of them. It's more than double-digit across the company. And actually, many of our customers are very interested about it because they are also trying to develop machine learning, so they're dealing with the same problem. So we're trying to see if this will bring any value proposition to them. And we continue working on this expanding autonomous design. Ultimately, really, that's what we would like to see. Can we really do it in some domains? Can we really getting that capability to help many of the designers to do that in more autonomous way? That's really what we are going after it. And there is many aspects of it. There are people which they want to use it to optimize their architecture or their performance. Many people dealing with the very large chips, which is extremely hard now to optimize all the performance of all these blocks they have. It's beyond just the CPU. It's a CPU, it's a GPU, it's AI accelerators. It is getting very big. And others, in many other aspects, they're looking at, oh, I need to develop more and more chips, but I cannot have enough designers. There is no way I can duplicate, or I cannot even build a kind of more design team so quickly. So it's, can we really have more capability to help, again, how to do design much more faster and more efficiently? And then we have all the IP. I think this is really to complement what Shankan said. We have many different IP from AVs to all the other IP, which is many of the chip developers need, not just for the way to develop AI chips, but pretty much anything in IC development. Quite interesting kind of portfolios we have. We continue improving it, but it is a part of the complete solution, I would say. Now, if you step back and you look at about, okay, how all these AI chip architectures look like today. As you know, most of the AI applications have been started using CPUs. That's what's available. That's how early programs would run first. And then they realized the GPU has this characteristic of the small core is just replicated so you can run more in parallel. And you can see in the bottom left the difference between, in the performance between using a CPU and a GPU. And people seeing like 3x more performance. And it's actually, that's what's helped most of the early training for all machine learning by using GPU-based machines. And then you have Google, which has been pushing very hard in terms of how to get even more data and more training. And they realized even with GPU, it's taken so long time. We're talking about not like hours or days. We're talking about months to complete trainings. So they decided to develop their own TPU. It's funny, the day when they announced they're developing their own TPU hardware for AI applications, that's actually exploded and opened the door for all these VC kind of investing on AI chips. It's like almost like this proof of belief. This is like something which it's going to be interesting for the future. But beyond that, you can have FPGA, you can have ASICs, and this is, in my view, only the beginning. If you try, and I've been working on AI for like more than a year and a half, trying to kind of follow all the publication, all the new things happening, it's just amazing. It's like almost every week there is new things coming out. And that comes back to this explosion of AI and all the learnings we are going through it as an overall industry. Now, when you think about AI and you think about hardware, it's a good thing, but you really have to keep in mind software is a big part of it. And we're going to have to get a much easy way to kind of standardize these things. And ONNX, it's really this kind of bringing this interoperability between all these different languages. It's extremely important. And you can see how the flow it's going. And I can tell you it's going to continue being evolving and improving through times. Now, when we talk with all these startup and many actually even the big company developing chips, some of them, they may have an idea and they may not go fast. So we kind of actually put this in place as a possibility for them to build very quick prototype. We call it the AI chassis. It's literally, think about it, we took an AI chip, which we built and we helped kind of build, and we expanded and make it, I don't say like a standard, but like more like a framework where you can very quickly develop a prototype. It has everything you need. May not be optimum for whatever you're trying to do, but if you want to go fast and you want to just kind of explore the possibility to build that AI chip for your application and see how it works, this is actually could be very good. And we connected back to our verification, emulation, prototyping systems, as well as the architecture exploration. So it is actually quite interesting. And some of the people actually, in reality, use it to build their prototypes. Some of them, they use it just to even start thinking about their new architectures, may not getting to use it per se as a prototype, but it could be an early stage to get started from developing new AI chips. Now, the AI requirement, and it's funny to talk about because any architecture, any chips, it really comes down and it's been developed around the requirement. And we know how a CPU or GPU or many other chip requirements looks like, but when we look at for AI, and specifically in the edge, the requirements are actually quite different. And usually that's always a sign of there's going to be new architecture coming out. So when you look at all these requirements, and this is what's going to get you to think about how all these things is going to evolve, there are, as any requirement, very kind of conflictual in many aspects. But the interesting piece of it, which is I want to highlight, is this more efficient bandwidth. Yankin said, yeah, we put like a new DNN with like 14,000 max on it. How you can really feed that monster engines you are building there? So it's almost like there is no infinite bandwidth, but you have to come up with some things how to manage now the bandwidth, how to be the most efficient possible to get the data. Machine learning, it's dealing with data, so whatever architecture you're going to have, you can always end up having data, managing the data as your critical path. And that's really the kind of, right now, what's driving many of these new ideas and how to optimize your architecture. The other one which I want to mention is power efficiency. And power efficiency has existed for many years. We talk about power even in the high-end servers, to even in my old time in mainframes, to today, including the mobile, which has really exploded in terms of the need of power battery, you can see in the automotive. But I want to kind of get you an attention about how we also tend to think about power and why it's even more important on the AI. I mentioned about all this machine learning need data, but what do you do with the data? You process this data. We're going to see an explosion of AI. Therefore, we're going to have more and more applications computing, processing data. Each time you process data, you dissipate power, as low power as you can think about it. We can have an explosion of demand of power beyond our belief. So it is extremely important to think this time in a very fundamental way how we're going to deal with power. Because it's not just about, oh, I need power to maintain my phone and life for the day or for 24 hours or my PC for the whole flight or the whole movie or the whole whatever times you defined. This is about power consumptions across all of us, across all the globes, because we're going to see this AI explosion everywhere, not just in our industry, but in healthcare and in anything you think about it, we will figure out how to incorporate this AI. And think about it now. Each time you think about AI, that means processing data. That means power. So this is the AVX. I'm not going to say more about it. I think Yang did a good job. I think the only point is, and I think Yang said it, we're kind of continuing improving and pushing in terms of architectures. We moved from CNN to DNN now. We have a ton of Macs. I can guarantee you this is evolving like in the speed of light. We are every month thinking about the new architectures, and we're going to have more and more things. And the funny things is like, if you look at what's happening in the academia and people like doing some research, they try to understand, okay, we're using DNN, it's working, it's great, but now you're starting a new application. It's like, okay, what is the depth of the DNN I need to implement? How deep it is, or what is the width? And they realize, actually, it's very difficult to come up with an optimum. And even we don't completely understand, because we can predict what is exactly the need of that depth or that width of that DNN, because many of the time we don't know where the data optimum it's going to be. So they try to kind of realizing, okay, actually the DNN works well on this particular part of the application or market, but you go to others, DNN may not work that well. So there's going to be a continuing evolution of these algorithm or this implementation of machine learning. So now, if you take an example, and I really wanted to get you to understand how AI people are implementing. So I'm talking about the AI accelerator, the chip, the connection of the processing, but actually things goes even beyond that. If you look at the automotive, the way how they need to think about their SoC when they try to implement AI, it's a complete roadmap. They need to think about it not just today, but even 5 years from now, where they're going. Because the demand in terms of performance and power, they kind of already have like a projection of it. So these batteries and all these kind of electrical vehicle, how they kind of really integrate all these new technology with AI, fundamentally you have to start thinking about your architecture today for 5 years. We always think about architecture for the long term, but here there is another, I would say, dimensions connecting to this power effect. Therefore, you really need to figure out how to have the tools and capability to figure out how to optimize this, how to really do your architecture, I would say, development, including power. And this is what's really we're trying to help out our customers, providing these technology and these tools and these capabilities so you can really have a view of what this architecture will look like with all these constraints, again, not just today, but many years from now. And the best example I kind of picked is Tesla. I'm pretty sure everybody have seen what they've published recently. It's actually a very interesting AI chip accelerators. They've literally have thought about it from scratch. Has very few instructions. It's a very heavily specialized to their own need about how to really get autonomous car to work. The way how they develop it, it's not just like okay, let's have like a chip and let's have machine learning and put it with like CPU, whatever. No, they build the whole system, including all their software. So very dedicated to this. And what's actually get Elon Musk to say, I already have all which I need from hardware perspective on all my car to do AI, to do autonomous driver. And I think he meant to say level 5. Now, he didn't say I'm there yet. He said, I still need to know work on the software, which means does he have all the data? Can he have all the learning? He has like all his fleet of Tesla running all across the globe and connecting all this data and doing all the machine learning and improving each time they have a new scenario, new situations in terms of how to really complement that capabilities. And he's doing it just with video cameras. And he said, we don't need more than that. It's actually quite of a statement. We know by kind of, in theory, machine learning, if you throw enough data, you will get to 99.99% accuracy. How are we going to deal with that 0.001% where the car would not recognize anything, doesn't know what to do? That's something I think as a human being we need to figure out how to deal with that or learn how to work with that. But this is actually a very interesting complete system-based AI where not just they have the hardware, the software, but they also have real collection of data happening every day. Cars have safety. I think Janken mentioned about it. It's very important. There's two things which everybody have in their mind right now. Power, as I mentioned it, as well as safety. And safety here in the car is easy to understand. But safety, it's going to go across the board because data requires all that safety. It is kind of getting a lot of struggle for all the legislations and how we're going to deal with it. Actually, I was in China a couple of weeks ago, and the government was talking about how serious they are about protecting data. It's actually very refreshing to hear that, frankly, knowing, oh, China doesn't have the same regulations as we have in the Western world, but they are taking this very seriously, at least what they're saying. Now, if you step back and you think about where we're going, okay, so we talk about all these things, we have all these applications, it's working, but how we think about the next really step forward. And this is actually a summary of everything we are learning so far from all our practicing about AI. First of all, pretty much 80–90% of all this AI machine learning are based on supervised learning, which means you really need to have these data and you have to label the data. More and more data you have, more and more labeling you have to do. And that's really causing a challenge right now. So there is a way how to get around it. Reinforcement learning, it's coming to play. People are using this to really kind of help out minimizing that work or getting around. The Bayesian algorithm is based on all these probabilities, probabilistic kind of a view. It's also a new path. People are looking at it. But it's still, it's related to, okay, this data, it's not stopping here. It's continuing exponentially exploding on us. Large data set. All machine learning need more data, but very often we don't have access to the data. So what happens if we don't have access to the data? How we can do this? So people try to say, okay, if I have a minimum of data, maybe I can do one-time learning, and can I kind of do by analogy to get the other learning? So that's one way to get around that. Explaining results. As I've said, many of these very deep learning, neural network learning, it's a black box. If you try to look what's happening inside, you really have no clue about what's happening. And in many kind of part of the many area or many domain or many industries, they really need to understand what's happening. They call it explainable AI. If you cannot explain to me why the data is this, I don't know how to use it. Actually, doctors, they don't want to play with that game. Unless you explain it, they're not going to touch it. So there is, right now, some area where can we simplify the network? Can we get you an idea about how this, what's happening within the neural network? It's one progress. There are other also kind of techniques to get explainable results. But it is an important thing. Generalization is the ultimate thing. You never get to it as an AI or machine learning. If you don't have the right generalizations, you are in trouble. If you are outfitting with the data, or you have the wrong generalizations, the same thing. It's going to get you the bad result. And it's not about accuracy. It could be a bad result, a bad decision per se. So the idea is, can we transfer some learning to another transfer? If you have a good generalization here, can we really transfer it to another? So that's really, I call them opportunity, but it's really the challenges we are dealing with it. Now, if you look at in terms of what would be all these driver for new architectures, and I put this in place to give you an idea about where we are. So in my right, or be in your right, I guess, AI will be a data hungry human being. We don't need all the time so many data. We can learn how to drive cars after 30 hours, 40 hours of driving. Tesla needs hundreds of millions of miles of driving to have any idea about how even to recognize how to drive on highway with having stripe in the middle of it. AI is very flat thinking. We definitely have capability to do hierarchical thinking. There is no causality on it. We only do correlations on AI. Human being can do causations, which is very important to that explainable AI. It's very static and biased with data. We can recognize when the world changes around us extremely quickly. It's amazing how much the brain can figure out what's happening around us and adjust to this. We also kind of tend to learn how to trust approximations. AI, it's a question, everything is about accuracy. So this is give you an idea where we stand in terms of what AI is capable to do for us and what would be going to the next thing. So how we can really, I would say, harness this common sense, or kind of, of course, I tend to call it reasoning of AI. We need more technologies. We need more applications. So deep learning, it's great, actually, technology. Surprised all of us in terms of results. I think it's going to continue pushing us and getting some understanding. Reinforcement learning, I mentioned about the Bayesian learning, the Bayesian algorithms. A new insight of advanced algorithms. I really do believe at the end of the day, if you want to explainable AI, we need to figure out what that machine learning is capable to tell us and incorporate it back to kind of an algorithm, which we understand. A performance leap with quantum computing, as I've said, it's real, and this will be phenomenal. I think it's there, but it makes us maybe a while to know how to program it and extract the information we know. 5G, as you know, it's going to bring us more and more data in real times. Again, that's going to feed all the monster of all the machine learning we are building. Silicon photonics, we would need that for performance, and we're going to have to figure out about how to deal with the power there as well as the new architectures. And I always finish by these things, which is tell you if really you're starting playing with machine learning and collecting all these data, this is what we call the big elephant we have in the room. And that's what you need to think about it. On that, I want to thank you.